What does the day-to-day development experience look like when you're working on microservices? I'm Mark Heath, and in this module, we'll look at some of the practicalities of building microservices. We'll start off by talking about some of the options for how microservices are hosted, as this has implications for development. In particular, we'll see why containerized microservices are so popular. We'll discuss the source control and build requirements for a microservice, as well as some of the standard features that should be present on every microservice. We'll look at the value of having a service template to work from, as well as a standard way of working that enables developers to productively debug and test their microservices in isolation, as well as in the context of the wider application. When we develop a microservice application, we typically want to run it in a variety of environments. Developers want to be able to run and debug the code locally on their development laptop. Testers might want to run the application in a staging environment, maybe in the cloud. And of course, we also want to be able to run our application in production. But how should we host the microservices? What should they run on? There are lots of choices here, and microservices doesn't dictate which option you go for. The traditional option is to use virtual machines. You could go for one virtual machine per microservice, but that can get very expensive, especially if you opt for having lots of small microservices. So alternatively, you might decide to pack several microservices onto a single virtual machine, but that can get a bit messy, as each microservice might have different requirements for frameworks or dependencies that need to be installed. And there are several other operational challenges with using virtual machines, such as how each microservice can know where to find the others. Another option is to target Platform as a Service, or PaaS. Many cloud providers offer hosted services where you simply provide the code for your microservices and they take care of a lot of the management and infrastructure, providing you with automatic scale-out and DNS entries for each microservice with load balancing built in. They often also provide security and monitoring features as standard. Serverless platforms fall into this category and are especially good at supporting what might be called nano-services, which are extremely small microservices that just do a single task. And I've actually created several courses here on Pluralsight about serverless architecture and Azure Functions, which is a serverless platform for Azure. So feel free to check those out if you're interested in learning more about this approach. A third option that's emerged as one of the most popular approaches to implementing microservices is to use containers. Containers let you package up an application along with all of its dependencies in such a way that it's easily portable to run on any container host. That container host could be running in the cloud, but it could also be your local development laptop. And this greatly simplifies the task for a developer who wants to get all of the microservices running locally. And tools like Docker Compose that we're going to be seeing later give us a really straightforward way of launching a group of microservices. Let's see how containerizing our microservices can make life much simpler for us as developers. We're going to be using the eShop on Containers sample application that we've been looking at throughout this course to see how containerization greatly simplifies the development experience and enables us to easily run the whole application locally. First, let me quickly tell you how I've set up my development machine in order to run this demo. I've installed Docker Desktop, which allows me to run containers on Windows. And this actually supports running both Linux and Windows containers. We're going to be using Linux containers for this demo. And this means that if you're using a Mac, you can also install Docker Desktop and run exactly the same containers. I've cloned the eShop on Containers source code from GitHub onto my local machine. And there were a couple of prerequisite steps on Windows that I needed to perform. One was that I enabled the WSL2 based engine in the Docker Desktop General Settings dialog. Another one was to add a Windows firewall rule that opens up some ports, and there's a helpful PowerShell script provided to do that. So here I am at the Windows command prompt, and I'm going to use a tool called Docker Compose to work on this project. And the first thing I want to do is build all of the source code for my microservice into some Docker container images. And so I'm going to use the Docker Compose build command to do that. And when I run this, it's going to go and build a Docker container image for each of the microservices in my application. And this is going to work regardless of whether I've got the .NET Core SDKs installed on my machine or not, because it's going to build the code inside another Docker container that's got all of the necessary SDKs installed. Now, the first time you run this, it is going to take quite a long time. It took about 10 minutes on my machine, and that's primarily because it's got to download a large number of container images that it's going to use as the basis for the containers that it's created. So I fast forwarded this to the point where it's finished building all of my microservice container images. And if we want to, we can use the Docker image list command to see the images that we've now got on our system. And you can see it's built a whole load of stuff, including images for each of the microservices. Now, to actually run our application, we again can use Docker Compose, and Docker Compose has got this really handy Docker Compose up command that will start a container for each of the services in the application. And again, the first time we run this, it will be a little bit slower as it needs to pull down some additional images for the third-party containers like SQL Server, Redis, and RabbitMQ. But the great thing about this is I don't need to have any of those applications running locally on my development machine. My microservices are going to be storing their data in containerized databases. And once it's downloaded the images for all of those dependencies, it's going to start up a container for each microservice as well as for each of those dependencies that we've containerized, and that will happen really quickly. So here you can see it's started them all up, and it's also started to show us the log output from each of these containers. Now, if you're wondering how Docker Compose Up knew what services to start, well, all it does is it looks at a YAML file that lists all the containers that need to be started, along with any specific configuration or environment variables that they need. And these files might look a little bit intimidating if you've never seen them before, but they're actually relatively straightforward. And it's very easy to add in an additional service to the list that needs to be started. By convention, the file that Docker Compose looks for is called dockercompose.yaml, and eShop on Containers actually comes with a variety of different override YAML files that can build on top of the base Docker Compose YAML file, which allows you to easily start the application in a variety of different configurations. As you can see here, in this file it lists all the services that make up the overall application. There's an entry here for each container, so here we can see a SQL Server and a MongoDB container, which are used for the databases when we're running locally. There's also a Redis cache and RabbitMQ for the message bus. For production, we might not run any of these services in containers and prefer to point at cloud-hosted databases or event buses. But for local development, this is brilliant. If we scroll down a bit further, we can see the entries for each of our microservices, starting with the identity microservice and then the basket microservice. You can see that these point at the Docker file that can be used to create the image for each microservice if it's not already available. And that's what was happening when we ran the Docker Compose build command earlier. Because it didn't have a local container image, it used that Docker file to build the container image. And if I scroll down a bit further, here we can see the catalog and ordering microservice definitions. Now, these containers should already have started up by now. So if I go to my web browser and we visit host.docker.internal on port 5100, we should see that the eShop on Containers website is up and running. And we can see here on the shop homepage that we can explore a range of programming-related merchandise. Let's log in, and the system comes pre-configured with a demo user that we can log in as. So I'll just copy in the username and password, And once we finish logging in, we can choose an item to buy and place it into our cart. Now let's go and look inside our shopping cart, and we'll click Checkout. We'll accept these default shipping and payment details, and we'll place our order. And so now we've added an order to the system, and if we want to take a look at the order details, we can do so here. And so as you can see, it was very easy to get this up and running, and those steps we just ran through exercised a number of the microservices in our overall application. And if you want to try this out yourself, you can do that really easily, whether you're on Windows or Mac. You just need to follow these Getting Started instructions that you can find on the eShop on Containers GitHub page. And this has got detailed instructions of all the steps that you need to complete, as well as some troubleshooting hints as well for common problems that you might run into. Now, I can't overemphasize how much of a game changer this sort of setup can be for developers. Imagine if I'd had to separately build and run each of those individual microservices, as well as install all of the third-party software like SQL Server and RabbitMQ, and configure everything to talk to each other. That would be a really painful process and probably take the best part of a day to complete. But using containers and Docker Compose locally makes it really trivial to get started. We were up and running in just a few minutes. Another great thing about this setup is that many modern development tools will allow you to attach a debugger to code that's running inside a container. And so I can get a very rich local development experience with this kind of setup. Now, obviously, containers are not a requirement for microservices, but if you are planning to host your microservices on virtual machines or platform as a service, then you'll probably need to invest some time into automating the process for developers of getting everything up and running and configured on their local machines. Because if you don't, as the number of microservices grows larger, the productivity of developers will drop off dramatically. So having something like Docker Compose that gives us a one-command way to start everything up really is invaluable.